We are given a row-wise and column-wise sorted matrix, and our task is to find whether an element is present in this matrix or not. So hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So please watch this video till the end. So let's get started. Alright, as you already heard about this problem, so let's do not waste time in reading this problem again. So let's directly come to the main point, that what does it mean by row-wise and column-wise sorted matrix. So here in front of you, you can see that here is a matrix. And if you closely observe this matrix, you will see that all the rows are arranged in ascending order, 1, 5, 9 and 12. And if you look at all the columns, you can see that the columns are also arranged in increasing order, 1, 2, 3 and 4. So whenever we have this type of matrix, we call it row-wise and column-wise sorted matrix. So now let's understand this problem with one example. Here we are given a matrix 10, 20, 30, 40, 15, 25, 35, 45, so on and so forth. And here the element needs to be searched is 29. And as you can see that this matrix has 29. So the output of this input is true. Now in the next example, the element needs to be searched is 100, and you can see that there is no element like 100. So in this case, we return false. So by now, I hope you understood this problem really well. So before we directly jump to the efficient approach to solve this problem, let me talk about the brute force and basic approach to solve this problem. So here we have a matrix 10, 20, 30, 40, 15, 25, 35, 45, so on and so forth. So what do we do in this basic approach? We simply traverse all the elements of the given matrix. And how we do it? We start from the first element, that is the first row of first column, and we traverse all the elements like this. And while traversing, we check if the current element we are visiting is equal to the searched element or not. If we found the element, we immediately return true. And if we did not find the element, we return false. This is the simple strategy to solve this problem. So I would say this is a simple and straightforward way to solve this problem. But the problem arises when we compute the time complexity of this approach. If you look at this approach, you can see that we are traversing each element at least once. So the time complexity of this approach comes out to be big of R into C, where R is equal to number of rows and C is equal to number of columns. In this case, number of rows are 4 and number of columns are also 4. Then 4 into 4 is 16. So we need to run loop 16 times to search whether the number present in this matrix or not. And this is quite strange. This complexity is too much. We have to do something to reduce this complexity. And to reduce this complexity, we have to closely observe this given matrix so that we can find all the underlying details hiding in this matrix. So on this note, let's move to the next section of this video, and where we observe the matrix and try to find out the efficient approach to solve this problem. Now here, if you look at this matrix, you can observe three things. First thing is, rows are sorted in ascending order, right? If you look at this 10, 15, 27, 32, you can see that all the rows are sorted in ascending order. Similarly, columns are also sorted in ascending order, okay? See 10, 20, 30, 40, 15, 25, 35, 45, and so on and so forth. And the third thing to observe that we can traverse vertically as well as horizontally. And we already know that in matrix we can either go from left to right or right to left, or from top to bottom or bottom to top. And these two facts, row and column, is already given in the problem. So what is the significance of these two facts, that rows and columns are sorted in ascending order? Can we use this fact to solve this problem? Because obviously if something is given in the problem, then there is a strong possibility that we can use this fact to solve this problem. Now let's say the value of x is 29. This means we want to search 29 in this matrix. So what we usually do, we choose the first position of this matrix, that is the top left corner, and then we search all the elements one by one. But if I ask you, did you ever think that why we choose this position specifically? Has this position some significance? I don't think so. This is just because this is the first row and the first column of this matrix. That is why we usually start traversing from this position. Now in this case, let's assume that we are at this position and we know that all the elements to the right of it is greater than this element, and all the element beneath this element is also greater than this element. And the question is, we want to find 29. standing on this position, if you look right of it, you find all the elements that are greater than 10. And if you look at the bottom elements, you find all the elements that are greater than 10. So here at this position, we cannot make any decision that whether to go to right side or whether to go to bottom side, right? So guys, today let's do one thing. Let's break this pattern and start traversing this matrix from top right corner, right? Because we have 4 options. Either we select this corner, and this corner, and this corner. Then why to select first only? We have other 3 options also. Let's start traversing this matrix from this position. Now the element at this position is 40 and this is not equal to 29. This means we have to traverse either on the left side or on the bottom side. Now if you look at the left side of this position, you see that all the elements are arranged in decreasing order. All the elements are smaller than 40. And if you look at the bottom of the 40, you will see that all the elements are greater than 40. Now at this position, we have option whether to go on the left side or whether to go on the bottom side. And we can easily make decision. And how to make decision? If the number is 29, this means that the numbers to the left of 40 is smaller than 40 and 29 is also smaller than 40, then we can safely move left side of the 40. If we had got any number like 55, then we simply move to the bottom of the 40 because 55 is greater than 40. Okay. So we cannot traverse to the left of 40. We have only one option, that we can traverse to the bottom of the 40 to find the number that is greater than 40. So for now, let's talk about the 29 first. Okay. So let's start traversing this matrix from this position. Now we check if 40 is equal to 29. It is not. But 29 is less than 40, so we go to the left of it. Now we reach to this position 30. Now again we check if 30 is equal to 29 or not. This time it is not. So again we have 2 options, either to go to left of it or go to bottom of it. As 29 is less than 30, we simply move left to it. We reach to 20. We check 20 is equal to 29 and it is not. So again we have 2 options, either we go to left of it or bottom of it. Now here is the trick. If we go to left of it, then we know that 29 is greater than 20. And if we go left of it, there is no meaning going left to it, because on left we always get number that is less than 20. So we can safely skip this path, right? So in this case, we decide to go to bottom of it. So we reach at this position, 25. We check if 25 is equal to 29. This time it is not. So again we have 2 options, either we go left or bottom, and there is no meaning going left to it because 25 is smaller than 29. And on the left of 25, we always see elements that are less than 25, right? So there is no meaning going left of it. So in this case, we go bottom of 25 and we reach at this position. Now we can see that this element is exactly same as 29. So at this position, we simply return true. This means we finally found element in the given matrix. So after observing all the facts, we just have to make 2 simple rules. If the element we are visiting is greater than the searched element, we simply move left. And in case the element we are visiting is smaller than the searched element, we simply go down. Okay, so I hope guys you understood this observation. Now based on this observation, let's devise an algorithm to solve this problem. And the approach of this algorithm is pretty simple. Instead of traversing the matrix from top left corner, we are going to traverse this matrix from top right corner. And while traversing, we check the element we are visiting is equal to x or not. If it is equal to x, then we simply return true. And if the x is smaller than the element we are visiting, we move to left. If x is greater than the element we are visiting, we simply move down. Okay? And at the end, if we cross the border, we simply stop. Okay? So this is the final and efficient approach to solve this problem. I hope you got it. Now let's move on to the next section and see how to implement this approach. So here you can see that we have a function search sorted matrix, and this function is taking matrix and element needs to be searched. In the first 2 statement, we are getting the length of rows and column. Okay? And then we are initializing 2 variables I and j. I with 0 and j with c. And the value of c is 3, okay, because number of columns are 0, 1, 2, 3. Then we are running this loop while I less than equal to r and j greater than equal to 0. And in each iteration we are checking if x is less than the element we are visiting. If this is the case, we decrement the j, and if this is not the case, we increment the I. And along with it, we are checking if the element we are visiting is equal to x or not. If we found element, then we simply return true. Okay? And let me explain you the base condition where our loop gets completed. We are checking if I is less than equal to r. This means, as you can see that we are incrementing I by 1 and we are starting I by 0. So we are visiting row 0, then 1, then 2 and then 3. Once the value of I reaches to 4, we simply break the loop. And similarly, we are beginning the value of j with 3. And in each iteration, we are reducing the value of j by 1. Okay? So when j reaches to less than 0, then we simply break the loop. So we are going to continuously run this loop till we reach this state where either I crosses the border or j crosses the border. Okay? So let's see how this code is going to work on this matrix. So initially the value of r is 3, c is 3, I is 0 and j is 3. We begin this loop with this position 40. As we can see that this is not equal to x, we check if x is less than 40 or not, and this time 29 is less than 40. So we decrement j by 1. So now j becomes 2. Okay? And I is equal to 0 only. Again we check if 30 is equal to 29 or not, and this is not the case. Now we again make decision 29 is smaller than 30. So again we decrement j by 1 and we reach here. And now we check 20 is equal to 29. This is not the case. So again we have to make decision whether to go to the left or whether to go to down. And this time 29 is greater than 20. So this time we move down and increment I by 1. So now I becomes 1 and j is equal to 1. Now 25 is also not equal to 29. So we make decision to go down because 25 is less than 29. Okay? So we increment I by 1. We reach at this position. And at this position we check if 29 is equal to x or not. And this time it is equal. So we simply return true. And this is how we are going to traverse the matrix to find the desired number. So I hope this is clear to you. So I have to say that this approach does pretty good job to solve this problem. But what about the time and space complexity? So if you look at this function, you will observe that either we are traversing all the rows or we are traversing all the columns. So we can assume that at max, we can traverse all the rows and we can traverse all the columns. So in worst case, so we can say that the upper bound of time complexity of this function is going to be big of r plus c, where r is equal to number of rows and c is equal to number of columns. And what about space complexity? As we are not using any extra space, so space complexity remains theta of 1, constant space. So overall, our efficient approach took big of r plus c time and theta of 1 constant space to solve this problem. So guys, I hope you understood this approach really well, and now you know that how to find any number in a sorted matrix, the matrix in which rows and columns are sorted in ascending order. So on this note, let's end this video. And if you have learned something valuable from this video, then hit the like button to make YouTube algorithm happy. Subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.